Hello class, this is lesson 7.4 where we will learn about nonlinear systems. So I wrote a nonlinear system here, and it's just a system where at least one of the equations is not linear. And as you can see, equation 1 is not linear because some of the variables are squared. So although equation 2 is a linear equation, since at least one of them was nonlinear, the system as a whole is a nonlinear system. And unfortunately, there's no general theory for solving nonlinear systems. You sort of have to take them case by case, and each problem will have its own unique quirks to them. But luckily for this class, they won't be too difficult of problems, so they're typically going to be solvable by using the elimination method or the substitution method that we have already learned about. So if you see an example like this, we could use the substitution method. Right? So if we think of this as equation 1, that equation 2, we could rewrite equation 2 as x equals y. And then we could plug that into equation 1, or we could substitute that into equation 1. So instead of an x, or let me just write equation 1 real quick, x squared plus y squared. I meant equals 1. And since x equals y, we could just substitute in a y for an x, right? Right, so we get 2y squared equals 1, y squared equals 1/2, y equals plus or minus the square root of 1/2. And let's sort of clean this up a little bit. So that's plus or minus, square root 1 over square root 2. That's plus or minus 1 over square root 2. And Pearson might be a little weird about writing a square root on the bottom for some reason, so you could just multiply root 2 to the top and bottom, which would give you plus or minus root 2 over 2. Okay, so anyways, to summarize, y either equals positive root 2 over 2, or y equals negative root 2 over 2. Okay, now recall equation 1, by equation 1, x equals y. So let me rephrase. So when y equals the positive root 2 over 2, x will also equal positive root 2 over 2, because in the system x equals y. When y equals negative root 2 over 2, x also equals negative root 2 over 2. Okay, so that's the solution, but another way to write this solution is as an ordered pair. X is positive root 2 over 2, y is positive root 2 over 2. Or x is negative root 2 over 2, y is negative root 2 over 2. So I believe this is how your homework wants you to write the solution. Okay, so that's the solution to the problem, but how do we interpret that graphically? Well, let me draw a graph of this. If we do equation 1 in blue, equation 1 was x squared plus y squared equals 1. That's just a circle with radius 1. Equation 2 was y equals x, which is this diagonal line here. Now the solution to the equation is the 2 points at which these two graphs cross each other. And if you check on an online grapher, you will definitely agree that the points do happen to be the root 2 over 2, root 2 over 2, and negative root 2 over 2, negative root 2 over 2. Okay. So this was an example of a nonlinear system in which we used the substitution method. Right, we plugged equation 2 into equation 1, solved for y. And we had 2 solutions for y, so we had to break it up into 2 cases. When y equaled the first solution, we just plug in, get x. When y equals the second solution, we plugged into equation 2 and got the other value for x. And that was our solution. So let me give you another example where we can use elimination now to solve a nonlinear problem. So let's consider the system x squared plus y squared equals 38. Negative 3x squared plus y squared equals 26. Okay, so here's our system. Now notice if we do equation 1 minus equation 2, we get x squared plus y squared equals 38 minus negative 3x squared plus y squared equals 26. So we do 1 plus 3, right? That gives us 4x squared. Then we do y squared minus y squared, it cancels. We eliminated the y. We do 38 minus 26, and we get 12. Right, so x squared equals 3 if you divide the 4 over. X equals plus or minus square root 3. Right, so we have two cases, either x equals positive root 3 or x equals negative root 3. And we plug in. And we plug in each case. When x equals positive root 3, well, remember, x squared plus y, what was it? Let me go back to the original equation. X squared plus y squared equals 38, right, by equation 1. Equation 1, I'm just plugging in for x. So, square root cancels, we get 3 plus y squared equals 38, y squared equals 35, y equals plus or minus square root 35, 35. Yeah, so we got two solutions for y corresponding to that one x. Right, so we have the solution root, root 3, positive root 35 is one of the solutions, and then another solution, root 3, negative root 35. That was just for the one case where x equals positive root 3. Now let's think about this case where x equals negative root 3. X equals negative root 3, we just plug in. You could plug into either equation, but equation 1 is easier. Right, that's just equation 1. So the negative root 3 squared, the negative will cancel. Again, we just get 3 plus y squared equals 38. Y squared equals 35. So y either equals positive root 35 or y equals negative root 35. So again, we get these solutions. We get negative root 3, positive root 35. We get negative root 3, negative root 35. So now we have 4 solutions. We have these and these. So if we write the solution in one list, it would be positive root 3, positive root 35. Positive root 3, negative root 35. Or negative root 3, positive root 35. Negative root 3, negative root 35. And that is the entire solution. Yeah, so you just got to be careful that you think of every case. Yeah, so in this example, we ended up having 4 solutions. Okay. Let's try another example here. Let's look at x squared minus xy plus 3x, plus 3y squared equals 15. X minus y equals 2. So this is a system, a nonlinear system. Notice we can rewrite equation 2 as x equals y plus 2. And then we could plug that into equation 1, and that will give us y plus 2 squared minus y plus 2. Oh, I don't know why I wrote that, sorry. y plus 2 times y plus 3y squared plus 15. Right, so instead of x in equation 1, I was just substituting in the y plus 2. Now we just multiply this out. So y squared plus 4y plus 4 minus y squared minus 2y plus 3y squared equals 15. Okay, clean it up. Notice y squared minus y squared cancels. We have 4y. We have 4y minus 2y. So that will give us a total of 2y plus 4 plus 3y squared equals 15. So that's 3y squared plus 2y equals 11. Let's bring everything to one side of the equation, and we have this quadratic equation. Now we could use the quadratic formula to get y equals -2 plus or minus square root 2 squared minus 4 times 3 times -11 all over 2 times 3. So that is -2 plus or minus the square root of 4, and then we have a double negative, so that will be plus 132 all over 6. Okay, so -2 plus or minus the square root of 136 all over 6. Now, Pearson might be a little picky and not like this, so notice we could break up 136 as, well, it's 17 times 8. 8 is 2 squared times 2, right? So square root of 136 is really like the square root of 17 times 2 squared times 2. Now, the reason I wrote it like this is because we have 2 squared and we have a square root. So really, that will cancel. We could pull that 2 out, and we just have 2 times square root 17 times 32. Now 17 is a prime number, so we can't really do anything anymore, so I have to leave it alone. 2 square root 34. Anyways, back to the original problem. We could, what we just figured out is we could simplify this square root as 2 square root 34 if we would like. Okay, so now this would simplify, right? We could pull the 2 out, we get -1 plus or minus 34 over 6. So 2 over 6 is 1/3. So this simplifies to -1 plus or minus square root 34 over 3. So we have 2 answers for y. Either y is -1 plus root 34 over 3, or y is -1 minus root 34 over 3. Okay, so we got to think about every case. When y is -1 plus root 34 over 3, let's solve for x. Well, we go back to the original equation. X equals y plus 2. We plug into to find x, right? So we get x equals -1 plus 34 plus 2. Right, this is y. Right, x equals y plus 2. Okay, so x, right, think of 2 as 6 over 3. So therefore y, or x is 5/3 plus. And Pearson is really picky in this section. You might need to write it like this. There we go. Similarly, when y is -1 minus root 34 over 3, x will be, 5 minus root 34 all over 3. Okay, so the solution, we will write either x is 5 plus root 34 over 3, and then y, that was corresponding to when y was -1 plus root 34 3, or we have 5 minus root 34 over 3, that was corresponding to when y was -1 minus root 34 over 3. And that is the solution. Okay, so that is how we will solve the problems in this section. You can either use substitution or elimination. You will typically have more than one answer. You just have to think about every case and be careful about that. And with that, we will end today's lesson. Thank you for